A very good morning, good afternoon, good evening to everyone present over here. Welcome to this free introductory session on the theme Refinery and Petrochemical by Mr. Kabidas Mandal, EX-CGM of IOCL. Overall 35 years of experience in Indian Oil Corporation Limited, 20 years in refining planning, coordination and optimization, 6 years of experience in unit operation of hydrogen generation unit, hydrocracker unit, feed preparation unit, and a production head of Mathura Refinery has DGM production. 10 years of experience in technical services job in Ancon, process monitoring, process project and offsets and utilities. At this time, I would like to tell that there will be an open Q&A session where you can ask your queries related to this topic. Now, without wasting time, I would like Mr. Kavidas to start this wonderful session. Thank you, sir. You can start.
Good evening to all of you. Thank you, Nikhil. Okay. Uh, this is my short personal profile. Just you can go through this. This is my professional trainings and job projects, which I have covered in my career. Okay, we'll come to the point. Uh, okay. This first introduction to oil and gas industry. We can divide the whole oil and gas industry into three major sectors. That is the upstream, midstream, and downstream. Upstream sector basically deals with the oil and gas exploration and production. This this sector is basically cost extensive and full of uncertainty also. In India, Oil and Natural Gas Commission, ONGC, Oil India, Crude India, they are dealing with this upstream sector for oil exploration, as well as there are so many operators in gas site in India. Midstream basically deals with the transportation of this oil and gas from the well site to the refinery and gas processing site through pipeline and shipping medium. So here, one of the major shippers in India, they are helping along with so many international shippers who are operating around the globe. Then downstream sector, this is from refining to product supply to marketing locations as well as to customer end. We will mainly deal with this downstream sector. To start with the downstream sector, first, it's the refining and processing of crude oil and gas. Crude oil is processed in a refinery complex. What is refinery complex? You can see that refinery complex consists of a number of processing units along with supporting infrastructure facilities. This is the first unit. We also call it mother unit, which produces straight run cuts, so straight run products. Now, depending upon the type of crude oil and the associated impurities, the straight run cuts are required to be processed further in secondary processing units and treating units to get the value added finished products. Regarding supply and distribution side, from refinery to marketing location and also to customer end, there are number of modes there. Pipeline mode, which is the cheapest and safest mode. Okay. Next is the rail, that is through tank wagon. Third is the road dispatch through tank truck, TT. And fourth is the shipping mode, that is through tanker or through vessel. Now, we will introduce about the modern and integrated refinery. What we can call it as a modern refinery. The modern refinery will consist of primary unit, various secondary units, and treating units to upgrade even bottom of the barrel to auto fuels and value-added products for improving gross refinery margin. Okay. So it will have number of units in the modern refinery for ultimately getting the finished products. Integrated refinery is a complex consisting of the refinery, the whole processing units in the refinery, and petrochemical units. So the integrated refinery means we can say it's a combination of two complex. One is the refinery complex, another is petrochemical complex. Okay, for producing auto fuels and value-added products and variety of petrochemicals for further improving gross refinery margin. Types of crude oil and finished products. We know that all over the globe, oil production is there. There are so many players, vendors, operators, companies, national oil companies as well as private companies. They are in this job. So there are number of varieties of crudes are available all over the globe. Say imported crudes. Okay, imported crudes, it may be high sulfur, it may be medium sulfur, it may be low sulfur, and some of the crudes we call it opportunity crudes. Okay, say the origin of high sulfur crude is, we know that the Middle East countries like Kuwait, Dubai, Saudi Arabia, Iraq, Iran. Those are the countries having huge reserve of this high sulfur crude. Medium sulfur, there are not many, but few crudes which are having medium sulfur, means the sulfur in the range of say 0.6 to 0.7% on crude. And low sulfur origins are and opportunity crudes also. We get from the African countries, okay, Malaysia, and then other countries, and latest from the USA. From USA, we in India we are also getting number of low sulfur based crudes as well as condensates. Okay. In India, also we are getting the crudes, indigenous crudes, which are by default they're having low sulfur. Okay, in eastern India, this Assam, where Oil India is operating, then in western side, North Gujarat, South Gujarat crudes, and in Bombay, we are getting Bombay High crude, Kaveri Basin crudes. Of late, we are also getting a lot of crudes from Rajasthan, Rajasthan crudes, which are basically low sulfur but heavy and viscous crudes. Okay, So we will in our full session we will discuss about whole of the crude available over the globe, and out of that, what are the crudes Indian refineries that uh, processing. Okay. Regarding finished products, uh, based on the configuration of the refinery uh, and the type of crude processed by the refinery, there are variety of finished products are produced in refineries. Okay, starting from that LPG, propylene, naphtha, superior kerosene oil, that is SQ, then mineral turpentine oil, and linear alkyl benzene feedstock, aviation turbine fuel. This SKO, MTO, LABFS, and ATF, these are almost having the same, more or less same carbon content range. Okay. Then high speed diesel, then light diesel oil, then fuel oil, low sulfur heavy stock LSHS, bitumen, wax, and LOBs, that is lube oil bearing stocks. Over and above this, there are other number of products which we also call it as value-added products, like organics or aromatics, benzene, xylene, then other products like hexane, butene one. All sorts of finished products are available from the refineries. Okay. So based on the crude processing, say for getting the bitumen, refinery has to process bitumen bearing crude. That is a high sulfur crude. We know that high sulfur crude is having the potential for bitumen. And normally from low sulfur crude we get fuel oil and LSHS. Then similarly for uh, production of wax, you have to have processed the particular wax bearing crude. So in India, we can say that Bombay High crude is having a good potential of wax, paraffin wax. Okay, and then in eastern side, in Assam, also this Assam oil, crude oil is also having a lot of wax for producing paraffin wax and other types of wax. There are other crudes, few other crudes which are having the loop potential. Okay, all crude cannot, loops cannot be produced from all crudes. So there's only loop potential bearing crudes. If we process in a refinery, in a loop based refinery, then we can get this loops. Okay. Okay. Next, we'll talk about the crude assay and details of crude qualities. See, crude assay, crude assay is a uh, gives number of qualities, crude qualities. Okay. First of all, we have to know that valuation of crude is dependent on what? Okay, price of the crude is dependent on what? There are a few specific qualities like sulfur, sulfur content, API gravity, whether it is a heavy or light, viscosity, TAN, total acid number, metal content, nitrogen content. So there are a few specific qualities based on which the price of crude oil is determined. Okay. Now, over and above these uh, qualities, there are number of other qualities which uh, we can go through the crude assay only. Okay, whether crude is a paraffinic crude, whether it is naphthenic crude, aromatic crude, olefinic, what is Puna? What is the Puna content in crude? Okay, then what are the other uh, properties of crude? These are known only through the crude assay. Okay, the crude assay is nothing but a bible for a particular crude. Each and every crude is assessed through the crude assay, detailed crude assay. Okay. Then in our full section, we will talk about the latest product specifications to the market demand. Okay. Uh, these are the specifications in India. It is BIS standard. In Europe, it is European standard. Okay. Euro, we call it Euro. So in India, we know that in uh, from 2000 April 2020, uh, the latest specification or market as per the market demand is the Euro 6 product. Okay, so in detailed specifications for the product, we will get each and every product with its uh, particular qualities which are required for maintaining the market specifications. Okay, we know that market specifications are as per the standards. Now, to meet the market specifications, refineries are supposed to maintain manufacturing specifications. Okay. What is called manufacturing specifications? The manufacturing specifications are nothing but the specifications with some stringent values. Okay, so that when it is supplied to marketing location through pipeline mode, through tank wagon mode, tank truck, or shipping, the product should not fail at the market location or at retail outlet locations. So to avoid the product failure at marketing locations or retail outlet, refineries are supposed to maintain the manufacturing specifications of the auto fuels. Okay. Okay. Crude distillation unit. As I told that mm, the crude distillation unit, we call it also the mother unit in a refinery. It's also called the primary distillation unit, where the crude is first received from the storage tankages and processed to get the straight run cuts. Straight run cuts we are telling because uh, in contrast to earlier days, maybe 15, 20, or maybe 25 to 30 years back, uh, most of the products produced from CDU unit uh, were sold as the finished product. Okay, where that time the specifications were not so stringent. So CDU, LPG, naphtha, uh, then superior kerosene oil. Okay, uh, mm, this these products were supposed to uh, go to directly to the finished products tanks. Now, with the stringent specifications, if we go back to the specification in bed, we see that first it was BIS. Okay, BIS one, then that is BS1, that then BS2, BS3, BS4, BS6. Similarly, it is Euro 1, Euro 2, Euro 3, Euro 4, and Euro 6. So these are the history of the uh, stringent product specifications has gone stringent from time to time. Okay, so to today's market scenario, almost each and every product from CDU is required further processing and treatment for selling in the market. Okay, so crude unit, which is basically uh, producing the straight run cards, will require further processing and trading. Okay, now the CDU is basically consists of atmospheric distillation unit and vacuum distillation unit. This atmospheric distillation unit we call it because the pressure, operating pressure of CDU remains almost to atmospheric pressure, maybe 1.1, 1.2 to 1.4, 1.5 in that range. So that's why we call it atmospheric distillation unit. And uh, vacuum distillation unit, which operates under vacuum, maybe 60 millimeter mercury pressure, or for loop based refinery it can go down further, maybe 30 40 millimeter mercury pressure balances vacuum. uh, and then this atmospheric distillation unit and vacuum distillation unit, it is integrated with each other for economic operation and energy conservations. Okay, for synergy of uh, energy, uh, as well as to uh, contain the to utilize properly utilize the heat content of streams coming from CDU to VDU. There, there is no storage facility available in between these two units. So it is integrated in the sense that streams from CDU directly goes to vacuum distillation unit with the heat content available. Okay, so it's a heat integrated. In that way, it is a heat integrated unit. So it gives a lot of energy conservation advantage. Okay, so when we'll discuss about details, we'll go further. What are the energy conservation steps normally nowadays we take in latest design of crude distillation unit? Okay. As I told that almost all straight run cards from CDU need further processing and treatment for production of finished products. Okay. So after crude distillation unit, then the streams goes to secondary processing units and other treating units. The secondary processing units are very important for a refinery operation. Okay, uh, for getting the value-added products, for upgrading the bottom of the barrel. There are number of secondary units are available. Now, some units are based on hydrocracker, either hydrocracking unit, waltz through hydrocracking unit, or residue hydrocracking unit. Uh, some refinery is based on this FCCU, fluidized catalytic cracking unit, or resid fluidized catalytic cracking unit. Delayed coker unit, this is basically the bottom of the barrel is processed in this delayed coker unit, which we call normally short residue or vacuum residue, that is processed in delayed coker unit. Now, latest earlier days, this hydrocracker unit or once through hydrocracker, it used to operate with the simple feed or single feed of vacuum gas oil VGO. Nowadays, there are so many units in operation all over the globe where this vacuum residue or short residue is the feed of the hydrocracker unit. Okay, so with higher operating pressure and temperature, and with the latest advent of catalyst series, we are we are we are having a lot of resid hydrocracker units all over the world, operating all over the world. Okay, uh, regarding fluidized catalytic cracking unit, which was also processing vacuum gas oil as the normal feed. Uh, Nowadays, there are number of units operating in India with uh, around 15 to 25% of short residue or vacuum residue along with the vacuum gas oil as feed. Okay, so uh, nowadays the refiners are targeting to improve the bottom of the barrel. Okay, to produce the value added product as much as possible. So for getting the or maximizing the value added products in the refineries, you have to have this type of receipt cracker unit. Okay, uh, alternative is delayed coker unit. Delayed coker unit is process the feed of this vacuum residue or uh, short residue as feed, and maybe based on the design, we get around 25 to 32% coke, petroleum coke from the delayed coker unit. Now, in case of delayed coker unit as well as fluidized catalytic cracking unit, in these two units, whatever streams are produced from the unit uh, need further treatment because uh, these products are having sulfur and other impurities. So, for getting the finished product, you need to treat further all the streams from FCCU, RFCCU, and DCU for getting the finished product. In contrast, from hydrocracker unit, which is basically uh, where cracking, cracking of the uh, heavier hydrocarbon molecules uh, is happening with by reaction with hydrogen. So the products, all products produced from SCU, SCU, or RSCU do not need further treatment. Okay, because it is the hydro treated products. It's a hydrocracking, cracking with the help of hydrogen. That means the heavier molecules getting cracked, and simultaneously hydrogen is added for saturation of the uh, streams, saturation of the components. So the products which we will be getting from SCU, SCU, or RHCU will be uh, totally, almost totally uh, devoid of the impurities like your sulfur, nitrogen, oxygen. Okay, uh, then in case of metal, there will be the catalyst bed which will trap the metals inside the catalyst bed. So it will remove the metal content also. Okay. Uh, Regarding this operations of these units, SU, SU, RSU, the cost intensive unit, high operating cost is high because it is operated at high pressure, like in the range of 140 to 180 kg pressure, and operating temperature is also high, maybe in the level of 380 to 450 degrees centigrade. Okay. In contrast, FCCU, RFCCU, and DCU, there's a uh, operating pressure of these units are at a lower range, maybe in the level of 1.5 to 3.5 kg per centimeter square gauge. Temperature maybe a bit higher, maybe 500, for 450 to 500, 510, or maybe receipt, in case of receipt FCC, it can go up to 540, 550 degrees centigrade. Okay. So these are the major three secondary processing units from where we get from from the middle distillate, uh, that is that is uh, the vacuum gas oil, which cannot be sold directly as a product. But through these units, we can get all the value-added products which we need as per the specification, as per the market specification, starting from LPG to diesel. Okay. In Wiesbaker unit, you can say Wiesbaker unit, it's a dying unit. Okay. Day by day, the importance of Wiesbaker is going down uh, because this unit is basically for producing the fuel oil. Okay, for producing fuel oil. Along with that, it gives a small amount of this naphtha and gas oil. Okay, so here basically we the viscosity of the short residue or mm, vacuum residue is reduced by heating the feed. Okay, so day by day, the importance of this phase breaker unit is decreasing because as I told that the refiners now look at to upgrade the bottom of the barrel. They are not interested to produce a lot of fuel oil and bitumen. There's low value products. Okay. CRU, CCRU, this is the catalytic reforming unit or continuous catalytic reforming unit. Earlier days, we used to call it CRU because this unit, uh, after running of 2.5 years, then it was needing the regeneration of the catalyst. Okay, but now it is the all modern refineries are having CCRU, that is continuous catalytic reforming unit. That means here the regeneration of the catalyst is continuous. It is not for a long time operation. It's a continuous regeneration of the catalysts with which, and this unit basically purpose of this unit to upgrade naphtha to reformate. Reformate having octane number nowadays we are getting from CCRU up to 105, 106 octane number. Okay, so this reformate is a major component of the petrol or MS motor spirit. Okay, which we get from this unit. Okay. There are number of treating units, as I told that due to invent of or due to progress of the specification, product specification from BS1 to BS6. Okay, number of treating units uh, have come up. We can just discuss some of the units. Say NHT naphtha hydrotreating unit. Okay, this is for uh, removing the sulfur component from the uh, naphtha feed before processing in CRU, CCRU. Okay. DHDS and DHDT is diesel hydrodesulfurization and diesel hydrotreating unit. These are the units where we receive the straight run gas oil from the crude distillation unit, and it is hydrotreated to remove the sulfur, uh, nitrogen, and other impurities. Okay. Now, earlier we used to operate this DSDS, uh, particularly for BS2 and BS3 production. DSDS unit was operating where the operating pressure is in the range of 30 to 40, 30 to 40, 45 maximum. Okay, and it was removing uh, sulfur impurities, nitrogen impurities, all these impurities with marginal improvement in cetane number, maybe 1, 2, okay, 1, 2 content, yeah, 1, 2 cetane improvement. But when the product specification changed from Euro 3 to Euro 4 and to Euro 6. This DSTS was not sufficient to uh, get the finished product. Okay, then DSDT, diesel hydrotreating unit, which normally uh, operates at a pressure of 90 to even 130. Okay, 130 and 40 uh, in that pressure level. Uh, so that unit, along with removal of all the impurities, it was also improving the cetane number. Okay, basically 6 8, based on the design, 6 to 8 cetane is improved, cetane number is improved through this diesel hydrotreating unit. Okay. So basically it is converting mm, the it is removed along with the removal of impurities. Some cracking is also going on. Mild cracking is also going on, and it is converting monoaromatic and diaromatic compounds, okay, to paraffinic compounds. Okay, we know that this cetane number is basically the functions of the paraffinic compounds. Okay. The more is the paraffinic component, more is the cetane we are getting, cetane number or cetane index, what you call, we are getting. So with the advantage, with taking the advantage of high pressure, along with removal of impurities, this unit is also helping to improve the cetane number as well as to convert the aromatics, monoaromatics, diaromatics, polyaromatics to the paraffinic components based on the pressure level it is operating. Okay. VGO HDT, vacuum gas oil hydrotonic unit. We know that vacuum gas oil we are processing in hydrocracker unit and fluidized catalytic cracking unit. Okay. Now, uh, due to the stringent specifications of autofuels, say in case of BS4, it was 50 ppm sulfur for diesel and petrol, and now in BS6 it is maximum 10 ppm sulfur in diesel and petrol. Okay, now to get this specification from fluidized catalytic cracking unit, uh, the feed VGO is required to be hydrotreated. Particularly, the refineries are processing based on the design level. Refineries are processing starting from 40% to even 90-95% of high sulfur nowadays. Okay, and we know that uh, for the existence of the refineries, for getting the margin of, of the refineries, you you have to increase the cheaper crude in your refineries. Okay, processing of cheaper crude. So if we say cheaper crude with respect to low sulfur, high sulfur, heavy high sulfur crudes are uh, naturally a cheaper crude. Along with that, the opportunity crudes, that is high tan crude and other heavy crudes, uh, these are uh, these are having lower price with respect to low sulfur or light crude. Okay, so for processing this high sulfur to a great extent, you have to have this VGO-SDT nowadays to get the feed with lower sulfur, so that when you will process in FCC unit, fluidized catalytic cracking unit, it will meet the specification of the petrol, diesel, and all automobiles. Okay, so VGO-SDT has come for meeting that requirement. ISOM is an isomerization unit, as a unit which increases the octane number of naphtha from, say, naphtha octane is in the range of 70 70 to 75, 76, and from that range, isomerization unit, naphtha octane is increased up to 85, 87, 89 level. Okay. LPG ATF meroxinate, that is basically to remove the impurities, sulfur impurities, mercury and sulfur, all these impurities in LPG unit and sulfur. And in ATF Merox, along with the removal of the impurities, for ATF we also need the heat treatment. Okay, in Merox unit, basically it is improving all the qualities of ATF from the Merox unit through the reactor and other equipments. Sulfur recovery unit. This is you can say this is required for each and every refinery to recover the sulfur from the streams. Okay, because without recovering the sulfur from the streams, you cannot or you cannot emit the gases to the atmosphere. So along with the crude processing unit and other secondary units, you have to have the sulfur recovery unit in each and every refinery for improving the quality of the gases before emitting to the atmosphere. Okay, and with that it gives the sulfur as a byproduct. Okay. Then we will talk about the petrochemical complex. What are the units? What are the products we get from the petrochemical complex? Okay. Now, in petrochemical complex, in India, we are having so many players. Indian Oil is one of the player who are having a petrochemical complex at Panipat and Paradip, and some units of Gujarat refinery is also producing some petrochemical products. Other major players are Reliance. Okay, Reliance is the major petrochemical player in India, and other companies there who are producing petrochemical products. Okay, so naphtha cracker unit is the mother unit in case of petrochemical complex. Okay, now this petrochemical feed can be naphtha, can be gas. Okay, gas also. Okay, so in India, we are having this naphtha as the feed for petrochemical unit. So naphtha cracker unit is the mother unit of this petrochemical complex. So there are other products which we get from the petrochemical complex. Based on that, there are variety of units. Okay. So MEG, there is monoethylene glycol unit, polypropylene PP, high density polypropylene HDPE, low density polypropylene. Okay. Then butadiene extraction unit, benzene extraction unit, pi gas hydrotreating unit. Okay. Over and above this, there are other number of units in petrochemical complex. Now, there's in case of integrated refinery, how we are improving the margin of the refinery. This petrochemical complex feed is naphtha. Okay, and from this feed, it is converting to value-added products. All petrochemical products are value-added products. Okay, price is very high. Okay, though the initial you need a good amount of initial investment for putting the petrochemical complex. It is also energy intensive unit, but in long run, it gives a lot of advantage with respect to this mm, high value production of continuous production of high value products from a petrochemical complex. Okay, and uh, there will be a lot of synergy between refinery and petrochemical complex, a lot of interchanges, uh, like utilities, hydrogen, and other feed from refinery to petrochemical and from petrochemical to refinery. Okay, so all this integration in latest refinery, we are really dependent on this petrochemical complex for improving the margin of the overall refinery. Okay. Now, refinery production plan and product supply and distribution plan. This production plan, refinery production plan, nowadays is totally based on LP modeling system. Okay, there's software available like RPMS, which is Refinery and Petrochemical Modeling System, or this is supplied by Honeywell. The PIMS, Petroleum Industry Modeling System. This is supplied by Aspentech. Okay, there are other SIMSI and other uh, software systems are there. Okay, so total refinery production plan is based on this LP model, which gives the optimized optimized result. That means it is meeting your production target, as well as uh, it is giving you the maximum margin from the refinery. Okay, so in that way, it it carries number of simulations, number of runs for maximizing the margin of the refinery. Similarly, this product supply and distribution plan is also based on LP model, the SAD model, supply and distribution model, and other models are also available there. Okay. This model is basically uh, considering all uh, taxes, all freights, all other inputs for uh, giving the best distribution or optimized distribution. Okay, based on the log, it is considering the logistics, uh, which product is required to be produced from which refinery, and how the product will be distributed through the economic mode. Okay, whether it is through pipeline, whether it's through tank wagon, tank truck, or shipping mode. So it is this supply and distribution model uh, considers all aspects to give you the um, logistically most uh, optimum product distribution. So these are separate model. So another model, that is integrated plan model. Okay, this integrated plan model is a combination of this refinery production plan as well as product supply and distribution plan. Through the integrated plan model, you can get the um, combined refinery production plan. So if any company is having more than one refineries, okay, uh, and number of marketing locations, number of marketing terminals and distribution systems, then this integrated model is helping for optimized production plan as well as for logistically optimized distribution plan. Okay, I'm giving an example. In India, Indian Oil is using this integrated plan model, just supplied by Honeywell, Tata Honeywell, that is RPMS. Indian Oil is having total 9 plus 2, total 11 refineries under the belt, and it is operating more than 450 marketing terminals. Okay, so it's a huge uh, circuit which is managed by Indian Oil, and total all refineries production plan and marketing, supply and distribution plan is governed through this integrated plan model. So we will talk about this in details. We will touch all these things, how this is done. Okay. Refinery gross margin. Now, after running the refinery, uh, basically the refiners will be interested to maximize the uh, gross refinery margin. Okay. So what is gross refinery margin? This is basically the net differential between the total finished products realization and throughput costs net of intermediate stock differential is termed as gross refinery margin. Or we can say that gross refinery margin is nothing but the difference between the sales value of the products minus the crude costs. Because in a refinery, we know that out of total costs, crude cost is around 90 to 93%. Okay, so we can simply say that gross refinery margin is nothing but the difference between the realization of the product sales and the crude costs. Okay, so the refiners mm, will need to know uh, how to improve the gross refinery margin. Okay, so this is basically uh, is a big subject. Okay, how to increase this margin? There are so many uh, mm, parameters starting from your plan, refinery production plan, and unit operations. Okay, uh, the unit operations in the sense both primary unit of that is crude distillation unit as well as the secondary units. What are the operating levels? What are the operating parameters? Your efficient operations of the units, uninterrupted operations of the unit, uh, all these things, and production of value added products, how you are planning to produce maximum uh, uh, maximum production of value added products, and with minimization of the low value products. Okay, minimizing the fuel consumption of the refinery. What are the energy conservations mm, are prevailing in the refineries, and uh, improve uh, how to improve the operating conditions of the refineries. Okay, how to minimize the loss, the processing loss as well as other um, losses in the refineries. Okay, so there are number of factors uh, are dependent for increasing the gross refinery margin, starting from input cost, that is crude cost. What are the type of crudes you are planning to process in the refinery to maximize the margin? Okay, starting from that to what are the value added products you are planning to produce to get the maximum sale value. Okay, so there are a number of parameters are involved for increasing this gross refinery margin. So in our in our tutorial program, uh, we will discuss about all these parameters to how to create the maximum refinery margin. That's all. Thank you.
Thank you so much, sir. And thank you so much, Partner, for joining this free introductory session. Actually, we are going to organize